Hello, welcome back to Wisdom Academy PH. So now we will discuss about the continuity of a function on an interval. This topic is the sixth lesson about limits and continuity. Last video we talked about the continuity of a function on a certain number. So now, instead of a certain number, we will check the continuity on an interval. Okay, so a function f is said to be continuous everywhere kung continuous siya at every real numbers. Tapos on the open interval AB, kung continuous siya at every point in the open interval AB. So sa lahat ng point doon. So kapag naman close interval, dapat at every point doon sa open interval, end on the right of A, end on the left of B. Kapag naman closed siya sa A pero open siya sa B, so dapat on the right of A, dapat continuous siya. Pero hindi na siya kailangan na maging continuous on the left of B. So, ganun din if A, B, tas close sa B, open sa A. Okay? So, paano natin malalaman if F is continuous at every point? So, to find if a function is continuous on an interval, we should find the possible points of discontinuities and solve for continuities at those points. So, hahanapin natin kung ano-ano yung mga point na posibleng maging discontinuous yung function. Tapos, yun yung gagamitin natin to solve for the continuity of the function on an interval. So, in general, a function is discontinuous where the function is undefined. So, pag undefined yung functions, ibig sabihin, alam natin na magiging 0 yung denominator or magiging negative yung nasa loob ng square root. Undefined yung function doon, ibig sabihin, discontinuous siya in those interval. So, kapag naman piecewise function, it may. So, kailangan natin i-check if it is discontinuous at the endpoints of the intervals. Okay? Okay. So, let's solve this example. So, discuss the continuity of f of x. So, first step, hanapin natin yung mga possible points of discontinuity. So, square root, maging negative siya if x is less than 1. Pero, this is only for x is greater than or equal to 1. So, dito, walang possible point of discontinuity. Pero, since endpoint ng interval ng piecewise function is 1, so 1 is a possible point of discontinuity. Tapos, dito naman, so meron tayong denominator x squared plus 4x plus 4. So, equivalent siya sa x plus 2 squared. So, ibig sabihin, possible point of discontinuity din yung negative 2. Since, if x is equals to negative 2, magiging 0 yung denominator. And pasok din siya dito kasi negative 2 is less than 1. So, pasok din siya dito. So, now, we shall find the continuity of the function on these points. So, first, sa x equals 1, so, let's find the value of f at x equals to 1. So, at x equals to 1, square root of 1 minus 1 is equals to 0. So, since it is a piecewise function, hanapin natin yung one-sided limits nila as x approaches 1. So, from the right muna. So, square root of x minus 1, this will be equal to square root of 1 minus 1 from the right to. So, this will be positive 0. So, 0. From the left naman, limit as x approaches 1 from the left. So, 1 minus 9 over x squared plus 4x plus 4. So, we will find the limit here. So, direct substitution lang. 1 minus 9 over 1 plus 4 plus 4. So, this will be 1 minus 1, 0. So, f of x is continuous at x is equals to 1. So, now, checking for the continuity at x equals to negative 2. Since negative 2 ay maglalay lang dito, so ito lang yung gagamitin natin. So, f of negative 2, alam natin na undefined siya. So, alam na natin na discontinuous siya. Pero anong type of discontinuity? So, first, let us find its limit as x approaches negative 2. By factoring, alam natin na equal to sa 1 minus 9 over x plus 2 squared. So, by direct substitution, 1 minus 9 over 0. So, since squared siya, alam natin na positive si 0 natin dito. So 1 minus infinity is equals to negative infinity. So since negative infinity siya at x approaching negative 2, we can say that f of x has an infinite essential discontinuity at x is equals to negative 2. Ayan. So another example, let us discuss the discontinuity of this function. So possible points of discontinuity. So unang-una ay 2. Since 2 minus 2, magre-result siya sa 0 denominator. So possible point of discontinuity siya. And pasok din siya sa x is greater than 0, yung 2. So pasok siya dito. Next is, since endpoint si 0, possible point of discontinuity din siya. Tapos, si negative 1 din, since endpoint din siya dito, so negative 1 din. And lastly, dito sa pangatlong function, so negative 4. Dahil maging 0 yung denominator at x equals to negative 4. So, ayun ang ating possible points of discontinuity. Ayan. So, first, let us find its continuity at x equals 2. At x equals 2, alam na natin na f of 2 will be undefined. Since the denominator will be equal to 0 kapag sinubstitute natin siya dito. Then, yung limit ni f of x as x approaches 2, alalahanin natin na since absolute value to of x minus 2, this will be equivalent to x minus 2 and negative x minus 2 at x greater than 2 and x less than 2. So, kailangan natin kunin yung limit niya from the left and from the right. Okay, so from the left muna. So, this will be equal to, using direct substitution, so this will be equal to 2 times 4, 8 minus 10 plus 2 over 0, 0 over 0. So, since it is an indeterminate form, kailangan muna natin siya i-factor out para makita if meron tayong makakancel. So, pwede na natin i-cancel out si x minus 2. Matitira tayo sa negative 2x minus 1. So, using direct substitution, makukuha natin na 2 times 2 minus 1. So, 4 minus 1, 3. This will be negative 3. So, ganun din, limit of f of x as x approaches 2 from the right naman. So, from the right, so this will be equal to, so cancel out lang uli natin to. So, 2 times 2, so 4 minus 1, 3. So, since the one-sided limits are not equal to each other, then the limit of f of x as x approaches 2 does not exist. And since the limit are not equal, so f of x has a jump discontinuity at x equals 2. So, next naman, we will find its continuity at x is equals to 0. So, at x is equals to 0, hanapin muna natin yung value ni function. F of 0, ceiling of 0 plus 1, be equal to ceiling of 1, which equal to 1. Next, we will find the limit of f of x. Since piecewise function siya, one-sided limits uli yung kukunin natin. So, x approaches 0 from the left. So ang kukunin natin is eto. Since we will be looking from the left of 0. So, less than 0. Again, yung technique natin, pwede tayong kumuha ng negative 0.1. So, direct substitution. So, negative 0.1 plus 1 So, ceiling na to will still be equal to 1. So, limit naman ni f of x from the right be equal to limit x approaches 0 from the right. Ito naman yung gagamitin natin. This will be equal to, so direct substitution, 2, since maging 0 lang naman yung mga may x, over absolute value of negative 2 is equal to 1. So since all of them are all equal to 1, so f of x is continuous at x is equals to 0. Okay, so next naman, find naman natin yung continuity niya at x equals to negative 1. Una muna, hanapin natin yung f of negative 1 niya. Ceiling of negative 1 plus 1 is equals to 0. Now, hanapin naman natin yung limit ni f of x from the right. So, from the right, ito yung kukunin natin. So by direct substitution, pwede natin gamitin si negative 0.9. So, ceiling ni negative 0.9 plus 1, this will just be equal to 1. So, lastly, limit ni f of x as x approaches negative 1 from the left. This will be equal to, since from the left na, ito naman yung gagawin natin. So, this will be equal to, by direct substitution, 3 over negative 1 plus 4 is equals to 3 over 3 equals to 1. So, the limit as x approaches negative 1 of f of x is equals to 1. Since the limit exists but it is not equal to f of negative 1, then f of x has a removable discontinuity at x is equals to negative 1. So lastly, we will check its continuity at x is equals to negative 4. So we know at x is equals to negative 4, it will have an undefined value, since the denominator will be equal to 0. So, hanapin naman natin yung limit niya as x approaches negative 4. So, by direct substitution, alam natin na magre-result siya sa 3 over 0. So, positive or negative infinity siya. So, for continuities, usually, hindi naman natin kailangan alamin kung ano yung sign niya. Dahil from this data, alam na natin na magkakaroon siya ng infinite essential discontinuity at x equals to negative 4. Okay? Ayan. So, if we continue checking yung limit niya from the right and from the left, we will get positive infinity and negative infinity. Pero tama pa rin na infinite essential discontinuity siya. Ayan. So in conclusion, f of x is continuous everywhere. So, kasama yung 0 sa pagiging continuous niya, except at 2, negative 1, and negative 4. Because f of x has a jump essential discontinuity at x equals 2, removable discontinuity at x equals to negative 1, and infinite essential discontinuity at x equals to negative 4. So, yun ang discontinuity of f of x. So, additional theorems for continuity. So, let f of x and g of x be continuous at x equals a, and let c be a real number. Then the following are also continuous at x equals a. Sum of two functions are still continuous at x equals a. So multiplying the two functions, it will still be continuous at x equals a. The quotient of the two functions, as long as g of a is not equals to 0, it will still be continuous at x equals a. And the product of a real number and the function will still be continuous at x equals a. So, using the theorem, we can find the continuity of f of x at x equals to 0. Dito, makikita natin na pwede natin tong i-sulat in terms of functions. So, f of x equals to, let g of x be equal to x squared plus 3, h of x be equal to 2x squared minus x minus 3, then I of x be equal to x plus 2, then j of x be equal to 3x. First, quotient of two numbers, since pareho naman silang continuous everywhere, since pareho silang polynomial functions. So, polynomial functions are continuous everywhere. So, they are continuous at x equals to 0. So, at x equals to 0, I of x will be equal to 2. Since the denominator will not be equal to 0, the quotient of two functions will still be continuous at x equals to 0. So, for j of x naman, since 3x is still a polynomial function, it is continuous at x equals to 0. So, ito, continuous at x equals to 0. Ito rin, continuous at x equals to 0. So, ang difference nila, still continuous at x equals to 0. So, finally, itong function na to, continuous at x equals to 0, and g of x, since polynomial function din siya, continuous at x equals to 0, then f of x is continuous at x is equals to 0. Okay. And another theorem. So, if f of x is continuous at x is equals to limit of g of x as x approaches a, then the limit of f of g of x as x approaches a is equals to f of the limit of g of x as x approaches a. So, ibig sabihin lang, kung napapaloob sa isang function si g of x and alam mo na continuous si f of x if hanapin mo muna yung limit ni g of x. Then, kukunin muna natin yung limit ni g of x bago natin siya ipasok sa loob ni function. So, equal lang tong dalawa. So, example, we will evaluate this function. So, una, try muna natin yung kunin yung limit nung nasa loob ng square root. So, by direct substitution, makukuha natin is 1 minus 1 over 1 plus 2 minus 3. So, this will be equal to 0 over 0. So, kailangan natin mag-cancel out. So, by factoring the denominator, we will get, so we can cancel x minus 1 here. So, magiging limit as x approaches 1 of 1 over x plus 3. Directly substituting 1 here, we can get 1/4. So, since the function square root of x is continuous at x is equals to 1/4, pwede na natin ilabas dito si square root and ipasok na lang yung limit na to. So this will be equal to 1/4 square root. So 1/2. So next theorem, if g of x is continuous at x equals to a, and f of x is continuous at x equals g of a, then the composite function f of g of x is continuous at x equals a. Ibig sabihin lang yan, if papasok mo si g of x sa f of x, and continuous si g of x sa a, tapos continuous si f of x sa g of a, then yung composite function nila ay continuous at x equals a. So, illustrate natin yan through an example. So, we should find an interval in which h of x with this function is continuous. So, pwede nating sabihin na f of x is equals to square root of x and g of x is equals to x squared plus 2x minus 3 over x minus 4. So, g of x is continuous everywhere except at 4. Since at 4, magiging 0 yung denominator niya. Yung square root function naman, continuous at x greater than or equal to 0. So, ibig sabihin yan, h of x is equals to f of g of x will be continuous at g of x is greater than or equal to 0 except at 4. So, hanapin natin where g of x will be greater than or equal to 0. So, to do that, kailangan natin alalahanin yung table of signs since g of x is a rational function. So, first, pag gumagawa tayo ng table of signs, ifa-factor out muna natin si g of x. So, g of x will be equal to, so, this will be g of x. And so, critical points is negative 3, 1, and 4. So, at negative 3 and negative 1, value niya is 0. So, pasok si negative 3 and 1. Pero at 4, alam natin na g of x will be undefined. So, hindi siya kasama dito sa range na. Next, we'll get the table of signs. So, sa table of signs, naghahanap lang tayo ng sign sa intervals na to. So, since ang critical points natin ay negative 3, 1, and 4, yun yung magiging endpoints natin. And so, from negative infinity to negative 3, ang magiging sign ni x plus 3 is a negative number. And kapag greater than na sa negative 3, puro positive na. So, sa x minus 1 naman, magiging negative siya if less than 1, positive if greater than 1. X minus 4 naman, negative pag less than 4, and positive if greater than 4. So, multiplying this, so negative times negative over negative, this will be negative. So, positive times negative over negative, this will be positive. Positive times positive over negative, negative. Positive times positive over positive, this will be positive. So, at the intervals negative 3 to 1 and 4 to infinity, g of x is equals to 0. So, therefore, the interval wherein h of x is continuous is from negative 3 to 1, close interval kasi at negative 3 equals siya to 0 and at negative 1 equal din siya sa 0. So, close interval. Union 4 to infinity. Open interval siya sa 4 kasi undefined nga siya sa g of 4. Ito, x is not equal to 4. Ang balidan to. This must be x squared plus 2x minus 3 over x minus 4. And so, that's for this continuity theorem. So, lastly, we will discuss about the intermediate value theorem. So, sinasabi ng intermediate value theorem, so let f be continuous on the closed interval ab where f of a is not equal to f of b. IVT states that for every k between f of a and f of b, there exists a c in the interval ab such that f of c is equals to k. Note that c may not be unique. So, ang sinasabi lang yan, for example, this is a and this is b. So, this will be f of a and this will be f of b. So, in this range from f of a and f of b, makakahanap tayo ng f of c. Let's say, gusto natin na ito yung f of c. So, makakahanap tayo ng c such that c will lie between a and b. Okay? And note that c may not be unique. So, kita natin dito na pwedeng dito yung c, pwedeng dito yung c, or dito yung c. So, may tatlong possible values yung c. So, ganun lang siya. Ayan. So, show that the following equation has a solution at the closed interval 1 to 5. Okay. So, to solve this problem, we will use the concept of the intermediate value theorem. So, una muna, hanapin muna natin yung continuity na tong function na to. So, to find the continuity of these functions, Ifa-factor out muna natin si numerator. Since pwede natin to i-cancel, so this will be equal to x minus 1. So since ito yung maging nasa loob ng square root, so dapat x minus 1 must be greater than or equal to 0. So x must be greater than or equal to 1. And x must not be equal to negative 3/4. Since kapag negative 3/4 siya, magiging 0 yung denominator. Pero since hindi naman to pasok dito, kahit ito na lang. So, yun ang continuity na. Since this continuous at x is greater than or equal to 1, then pasok si 1 to 5. So, since continuous siya at 1 to 5, we can use IVT dito. So, we will find f of 1 muna. So, f of 1 ay, so this will be equal to square root of 0 over 7 equals to 0. Ngayon, f of 5 naman. So, this will be equal to, so this will be 92 over 23, which will be equal to square root of 4 will be equal to 2. Okay. So, since f of 1 and f of 5 is equals to 0 and 2, and 1 is between 0 and 2, therefore, by IVT, there is a number between 1 and 5 such that this will be true. In fact, f of c is equals to 1 at c is equals to 2. So, that's it for the continuity on an interval. Our next topic will be about the limits of trigonometric functions. I hope to see you there. Thank you.
Thank you very much for watching this video lecture made by Wisdom Academy PH. If you want to join our mission of providing high-quality educational videos for all Filipinos free of charge, then please consider supporting Wisdom Academy PH by contributing or donating to the following accounts. Kung interesado naman kayo maging parte ng aming organisasyon bilang isang volunteer educator, upang makapagbahagi at makapagturo sa mga taong nangangailangan, then please proceed to this link. If you like this video, then please hit the thumbs up. And if you want more educational videos like this, then please subscribe to Wisdom Academy PH and hit the notification bell for more updates. Watch and learn. God bless, and see you on the next one.